in the class? Chat box it was there. I don't remember his name. It starts with H.
Ma'am, I think a few more students are yet to join.
Oh. Why class is not over?
Class is over, but timing is not 2:15. So I think some students are joining.
Okay, fine. Yeah, Hiranmai Mahanta. So he was asking how, ma'am, how to realize the logic gates. Okay, and how the master clock generators generate pulses. So is he there in the class? Hiranmai? No, not yet.
Hello, ma'am.
Yeah, Hiranmai. Yes, he is there. Okay. Fine. You are asking so quickly, let me answer you. So first I'll start with the clock generator. So in your analog electronics, you might have heard the word 555 timer. No. See, if at all you don't
No.
No.
answer, you have not heard of this. This is an IC available, all right? So this particular IC works as a timer. That means it generates signals which is having a stipulated time period, and the time period can be adjusted if at all we use R and C values. You know the RC is a time constant, correct? It's a time constant, correct? So this time constant can be dictated with the selective R and selective C so that we can fix the time period, and these passive elements will be attached in a circuit along with this 555 timer, and it can act as a generator. Signal generator, not signal generator, in fact a pulse generator, fixed time periods. But if at all you want to have a better quality, like if you want to have the time period in microseconds and nanoseconds, this R and C, because these are passive elements and frequency oriented, it's very difficult to do that. So we will be having alternative, like we will go for higher oscillators such as what? Crystal oscillator, Hall-Pitts oscillator, Colpitts oscillator. I think this you might have studied in your analog electronics. You have studied oscillators?
No, ma'am.
No, no, ma'am.
Huh?
No, ma'am.
You have completed analog, na?
No, ma'am.
Oh, analog electronics is not over.
Yes,
Next
ma'am.
semester.
No, ma'am. It was in the previous semester.
Ah,
But
that's
we
what
have.
I was thinking. So in the previous semester, did you study about the oscillators?
Ma'am, nothing about
No,
Ma'am,
no, ma'am.
ma'am left. So due to time
Time
constraint.
constraint, so ma'am couldn't complete oscillators.
Oscillators. Oscillators was not completed.
Ma'am.
No, ma'am.
Till
Op
when?
amp had
Ma'am, she
high
barely
frequency
completed op-amps, ma'am.
response. Frequency response was completed.
Okay, okay. So in that only we will get this all clock generators and all. Right. So anyway, so if at all we have time, we can discuss. But I see 555 timer is then the lab experiment. That time I can explain you much better. So that acts as a clock generator. Right. So anyway, the second question, because if at all I start this digital to analog, I will shift. So right. Second question is how to realize gates. Is that correct? But your question is vague. Like which gates you want to realize?
Means by
What is that? Please come again. I cannot hear you.
transistors.
Oh, by transistors. Oh, anyway, that is a part of the circuit. So we can, I will do that. By analog devices, no, that I will do. Anyway, it's a part of the course. I will do that. It is called transistor logic, diode transistor logic, DTL logic, RTL logic, DTL logic, RTL, then TTL. This all is there. These circuits are there, I can tell you. Not an issue. Not a big deal. Okay. So this is a part of the course, I'll tell you. Right. So anyway, what exactly, where did we stop? Yes, we were in the minimization process, correct? So in the minimization process, yesterday I have gone through the 2 variable, 3 variable, 4 variable, right? So now, and we claim that we can reduce the Boolean expression so that we can use minimum number of gates to build the circuit. That's what is the claim in the last class. Is that correct? So now, in that case, for example, we can have to take some examples so that how to minimize using K-maps. Right? This is just a brush up or what? We can say this is just a revision. What you have done earlier. Correct? So now, in order to take a 3 variable, right? Let's take this way. 3 variable is like this. So there is x, y, z. So f of x, y, z. So this is the circuit. I mean, this is the expression given to you, x, y, z, which is, just a second, let me just check out, x dash, y, z dash. The dash means it is complement. Is that correct?
Yes, ma'am.
So this is what given. Okay, so they asked you to reduce. Now you have 2 methods. Either you can go with the postulates or theorems, or you can directly go with the K-map. Right. So now since we have already revised the K-maps, we can utilize that so that we can first write this expression in a sigma format, which is the representation of a min term sigma m, we will tell, or only sigma. And what is this min term is? This is 0, 1, 0. How much it is? 2. This one is 0, 0, 1. So it is 1. So this is 1, 1, 0. So it is 6. So this is your given problem. Is that correct? So problem is provided to us. As usual, we will remember that 0, 1, 0, 1, 0. Right. And now here extra thing is, I will add this is x bar, so that it will be easy for me to understand that here to what min term is there. It is optional. You can do or you need not do. Right. Here it is z. This is z bar. See, all the books will not be having. If you want, you can keep. Otherwise, you need not keep. But you should remember. You should understand that what exactly is happening. Right. This is the z. Z is taking here z naught. Here it is taking in these 2 spaces. It is taking 1. Here it is taking 0. Similarly, y dash 1. Okay. So now, wherever the terms are given, we will mark them. So mark them using 1. Okay, that is the formality. We will. That's a procedure we follow. So where is 2? 0, 1, 2. 2 is this point. If you want, you verify with the yesterday's class. Okay, 0, then 1. I think is this. These are the terms provided to us. 1, 2, and 6. Is that correct? Locations are fine?
Yes, ma'am.
Yes, ma'am.
Okay, right.
Yes.
So now, once the distributed things are ready, so what next we have to do? We have to try to merge them using the same concept. What yesterday I was telling, that if they are close, 1 step distance, we can combine them. Right. So now you can just start with this. Do we have anything close to this, like this side, this side, this side, this side? Nothing is occupied. So this is a lone lead. Okay, so we cannot go and club this one to anything in this situation. Why? Because nothing is available. Right? Is that correct?
Yes, ma'am.
Okay. Now, if at all you take this one, you have an adjacent one. So I can club this with. So now this is a clubbed one. So this equation, this particular club, what value is this? It is having x and x bar. One is in x and another one is in x bar. So they both will get cancelled out. Why? What it is? It is in the y zone. Both of them are in the y zone only, and it is both of them are in the z zone. So its term is yz dash. So what happened when I combine two terms, two given terms? So what will happen? One variable is reduced. Because see, again I will repeat. This one, this particular one is in x bar. This is in x. So both of them will not be working out. So that will cancel out. So both of them are in the y zone. Another one is in the z dash zone. So it is like this. So now coming to this one, this particular stuff, it is not clubbed with anything. So it remains what? It remains as it is. Its x dash is there, its y dash is there, and it is z. So it remains as it is. So the reduced form f will be, which is x, y, z provided, is y, z dash plus x dash, y dash, z. This is the reduced form. Other than this, we cannot reduce. Do we have an option to reduce?
No, ma'am.
No, ma'am.
So we don't have an option, means we need not take. Correct. So since this is the minimal one. Okay. Now example is quite easy. Now let's do the same thing, three variable in a different fashion. Okay. Not for this example. I am reworking. Right. Not for this. It is a three variable. Okay. Think that the provision I will try to do. Okay. So we are having again saves. Okay, so the given problem has, these are the given problem. Okay, something, what I can say, some function f of x, y, z is provided. Okay, so this is all given. Think like that. Now we are trying to club them. Okay, so now procedure of clubbing two you have already seen. So if clubbing two is possibility is there, how many variables are reduced if I club two? That means if I make a pair, you are reducing one. If I make a four club, that means if I club two pairs together, make a what I should say, quadruple I can say, four together, right? I can make four together, otherwise I can make eight together. But we have some rules to be followed there. Okay, now let's start. Let's understand the rules. This is only a revision. Okay, so let's understand the rules during the problem. Okay, now which one I will start with? So I can start with this one. Okay, so this one has the capability to pair with two. Why? Because it is next one is joint and this one also is there. Okay, so now I can make like this so that this term is trying to accommodate in that pair. Okay, and I can make a pair like this also, right? But think carefully. Whenever you are making a pair or a quadruple or an octet, right? Each combination should have at least one term which is used only once. Carefully understand. Again, I will repeat. Each combination, whether it's a pair, octave, quadruple or anything, right, should have at least one term which is used at least once. Then only those pairings or those octaves or those quadruples are valid. Right? Now let's verify whether it is following that system or not. Now here what we are trying to do, we have paired it, right? Now let us see. This is my first pair and this is my second pair. Okay, so in fact I will put the second pair in green. This is okay, second pair. Now, the first and the second pair, are they valid or not? Is valid or not valid? Valid? Because see, in the
Well,
first pair,
well,
this is there which is mapped only once. In the second pair, this is this term is there which is mapped only once. Right? So first and two pairs are valid. Now, the next choice is if I become greedy and then take this one, this blue color mark, is it valid?
No, ma'am.
Why?
Not valid.
Why? Because it is violating the rule, right? We are very eager to pair it, but check properly whether that pair is valid or not. It cannot be. Why? Because we don't have any terms left out, right? So this is already utilized more than once. So we cannot do that. So you did this. Just a second. So you have done this. So we will complete. Right. So now left out portion is what? So we have another option. I'm very bad at this maintenance. So I can make this pair, another pair like this. Is that fine? Right? All four pairs are valid?
Yes, ma'am.
Okay. Right. So now you are very happy.
Ma'am, or we may have done M2, M4 also.
What is that now?
We may have circled M2, M4 also.
I have come again. I didn't understand. M2.
M2 and M4 position.
What did I do there?
Ma'am, we could have done that one also.
This one. Yeah, I have done the other possibility. Right, it could have been done means why? Already I paired them. Again, why I want to pair another one? Already they are in a pair.
No. Instead of doing M4 and
yes, we have alternate solutions. Yes.
yes.
See, now once this is done, I got how many pairs? 1, 2, 3, 4. Right. But internally, I didn't express you. But internally, I was seeing that. I'm so sorry. I'm so sorry. Okay, I'm so sorry. This follows your first year's only. Right. So now, internally, what I was thinking that, do I have an option of making a 4, like 4 together? Here, in this particular problem. 4 cannot be combined because my situation is very bad here. 4, I cannot. Had it been a value here, I could have made a 4. Had it been a value used here, I mean utilized, so I can make a 4. So I am left out with pairs. So always remember, whenever a problem is provided to you, you should have in your mind, first aim big, whether I can make octaves or not. Right? Second thing is, if octaves is not possible, then think for quadruples, 4 together. Then go for pairs. So in this problem, this is one option. Right? So somebody is pointing out there can be another possibility or another solution here. So how I can do that? Let it go. Right. So let me keep only the skeleton and let me see another possibility. So as you said, then once this is done, I can do a reduced form that I can do later. So I can do 1, 1, 1, 1, this one. Right. So now I can do a possibility like this, like this, like this. Nothing wrong. Correct? This is also one expression. Yes or no? How many terms? 1, 2, and 3. In fact, this is the best. Here how many I got? 1, 2, 3, 4 I got. 4 pairs. Did you see? Here I got only 3 pairs. This is one possibility. So now another possibility. See, so many possibilities we will get. Not necessary I will got, and we should get the best in that. So now, as one boy has pointed out, so he told that we will take these two That means why I can combine this one and this edge, by the way. Again, back to the basics. This box and this box, are they one step away?
Yes, ma'am.
Yes. So we can combine. Yes, and both are occupied. We can combine them. Otherwise, your teacher might have taught if you fold it in the middle and they are matching with each other, then also they can be combined. I think that word they might have used. If you fold it to the middle, this graph, if at all you fold like this one will come upon this one. And they both are occupied, means you can make it as a pair. And we will draw like this. If you can see properly, this one. These two can be combined. Is that correct?
Yes, ma'am.
Yes or no?
Yes, ma'am.
So next possibility, I can take this one and another one I can take this. So how many? So again 1, 2, 3 pairs. This is another. This expression and this expression are completely different. Do you agree?
Yes,
Yes,
ma'am.
ma'am.
So
ma'am.
correct now. So now listen. Any more possibilities? Let's venture out. Any more possibilities for the same problem? I'm drawing only skeletons. So lazy I am. Right. You can also work out if you want. Right. So any more possibilities? I don't find. The minimal possibilities are these two are for 3 and this is for 4. Anyway, this is ruled out because 4 possibilities instead of that I have 3 pairs. This is much easy rather than that. Right. So this possibility in this you can pick anything. Is that correct?
Yes, ma'am.
Yeah. So we have an option provided for you any given number of terms. Right. We can reduce it using the map method. Okay. We say this as map method. Right. Now a question comes. This one, for example, this function, if at all I am writing f is equal to or w, sorry, w equal to what is this pair form? I will use this only. What is this pair? X and x dash won't be there. It will be y and y bar, z bar, plus for the second pair it will be, somebody should help me,
X bar Z.
x bar
Complement Z.
z plus this one right, correct for this one. Yes or not? Can I do that? Is it
Yes,
correct or
ma'am.
not? Okay. Now, so once
Yeah.
my function is ready, which is w is the function which is having x, y, z are the variables in that. Now, if at all I want to find out w bar, that means complement of this function using the same map, can I do? Using the same map, can I do the complement of this function?
Yes, ma'am.
Right. So now you might be having your own shortcuts. So which one? Like see, utilizing the same map to find out the complements, what exactly variations we have to do. That is more important. Correct. So what we can do, complement means what? Which are not utilized has to be highlighted. That is what complement. Correct. Complement means what? It is negation. Complement in digital terms, not as a gift sort of thing. It is in digital terms, it is complement of the original one. That means whichever is not filled up, we are trying to take. So here I can see the unfilled terms are these two boxes. Correct? In this particular problem. So this one, and this one. Right? So these two terms are used in the complement. Correct? To frame this complement function. But how it has to be utilized? Should I use the same regions or should I change the regions also? See, I'll tell one option. Because this is there and this is there. Now think that these are not existing. Right? These pairs are not existing. Complement, now we are thinking. So this one, how I will write the expression for this particular one? Can it be paired with anything? Now these green only are existing for me. So what will be the expression for this? Can it be paired? No, no. So this one is what? M2. Correct?
X bar
X bar
X bar Y Z bar.
exponent.
What about this?
X
X
Zero,
Y
one.
Y bar Z.
y bar z.
bar Z.
X, Y bar Z.
Right. So now, is this the complement of this?
Yes, ma'am.
Sure. See, we will go for brute force method also. What? You take the whole complement, or the whole complement of the canonical form. Are we landing up in this or not? We can check out that. Is complement taught for you? Some classes they might have taught, no problem. So in order to get a complement, this is correct only. That's what we are trying to tell. So complement form means what? We are trying to utilize the unused in the original function. These are all used. So in the complement function, these are used. But writing this form is correct or not, that's what the question stops. Can we get this is correct? Or should we write in some other manner? Out of 100 students or maybe 90 students, one also is not, the network is not proper and nobody is able to answer.
Ma'am, or else we can check by putting W bar.
That is what I was telling now. So W bar is there. We are getting this. Okay. How I will put W bar?
Means in the above expression, we will use the rules and simplify.
That is
Ma'am,
what I
by De
asked.
Morgan's theorem.
Yes, that's what. So where is the original expression? Original expression I didn't write at all. So it is sigma m. So 0, 1, 2 is not used, 3 is used. Then afterwards, oh, here is. Then 4 is used, 5 is not used, 6 and 7. So this is my original expression. You can write this as in canonical SOP, right? Canonical SOP. Then fill it up. Then afterwards reduce it and then get it. Otherwise, now if at all you do the whole complement here, that also you can do. From here you can start or here you can start. So if at all you do, what will happen? Are we lining up in this? Cross verify. Please cross verify. And who, if at all you are complete, please post it. I haven't seen any postages. Any posts? Let's see. So anybody is trying to, you can post in the chat box also, no problem. Very slow.
We are getting that expression.
We are getting the expression is not the thing. Okay, whatever you have done, just share the screenshot. I don't know who is talking.
Handwriting is not that good.
It's fine, ma. I'm Manish Kumar. Yes? No problem. We are not keeping a competition here. Okay. Right? See, we are all in a group now. So we have to understand each other. Then our positive, our weakness, everything. Yes, Komalika.
Ma'am, I have done LHS equals to RHS.
You have done LHS is equal to RHS. Right. So two people confirm. So anybody else to confirm? That means we can find a complement of a function, right? Given a function, right? Reduce its form and to find out the complement, use the unused minterms in the regular function and then make the pairs. But here in our system problem, we don't have the opportunity to pair them. Why? Because the green marks are there, they are not eligible for pairing. Correct? In this problem, not necessary all the time. Okay, remember that. Okay, now question comes, can I get a dual form of this? You know the dual form? Yesterday we are discussing?
Yes, ma'am.
Yes. A dual form of this means what we have to do? A dual form is nothing but a SOP form to POS form, right? But using the same map, we can do that or not? Yes, we can do.
Yes.
What? You can use the same complement method, but instead, what we have to do? We have to use the areas in a different manner. How we should do? This 0, 1 is supposed to be X. And 1 means it is supposed to be X bar. Just reverse. It has to be reversed. So now here, W dual. I mean, dual of W. How much it will be? This one will be X. We have to use in what? POS form. So this will be X plus. What is here? It is Y. So it will be Y bar plus. Right? This is one term. The second term is this one. This is what? X bar plus Y plus Z bar. Is that correct? The same map. You can find out a complement. You can find out a dual also. That means this is of pivots. Is that correct? See, occasionally, I am not here to confuse you or anything. See, it is not necessary always we will use a min-term option, right? But we are used to that, so we are going for this min-term operations. We can go for max-term operations and get reduced form also. No problem, right? So from the same map, what did I do? I have changed the regions only. Did you map here? See, did you check here? This is X bar in the min. But here when I am trying to find out W, I utilize this as X instead of X bar. Did you observe the difference? Have you observed the difference?
Yes, ma'am.
Yes, ma'am.
Yeah, that's what is the problem, right? So now what is this? From the same K map, we can get the complement, right? So just for practice, let us keep a function and then try to work out what is its reduced form and this one. Okay, now take down. Please take down. A 3 variable. Okay, let me check out here any problems are available. Otherwise, I will give it on my own. Okay, consider a 3 variable map whose min terms available are 1, 3, 6, 7, and 0. Okay, right. So function is with ABC, right? Sigma n, right? Okay, find dual of F, right? First, minimize this. Okay, this is second bit. First bit is minimize F. Use K. Right? So, whoever does, please post. You're doing or sleeping? Supposed to be doing, right? Very uninteractive. These kids are. Okay, Shweta, you have decided extra class will be on 10 a.m. at 10 a.m. every Wednesday. Fine, thank you. So that means tomorrow I will be having 10 o'clock.
Yes, ma'am.
Okay. But I am waiting at least now. So many posts I should get. All the students should be a bit active. Missing out all the classroom teaching. We are literally, these used to be very nice. We used to fight in the classes while we are doing these problems. Hmm. Am I getting any posts? Put it in the chat box, no problem. Those who are completed. You had classes today? Very poor network here. I think now all classes are on, that's right. Are you guys? Am I missing? No posts. No posts. Okay. Okay. So Somesh, Priya. Oh, super. Very nice. Very nice. So I have. See, I think everybody can see everybody posts, right? Good. Good. Right. Very good. So okay. So you got this. So first answer is C plus AB it seems. Okay. Second answer is what? Shweta has given something. So I was like Shweta, C plus AB. And the one is C dot A plus B. So stop. Good. C. Oh, good. Oh, yes, and Abhishek Sahu. Very nice. Majumdar. So finally, it is around 3 variables only they are having in the final reduced function. Is that correct? Am I there in the meeting or I am out? Yeah, I am there.
Yes, ma'am.
Yes, very good. Oh, someone is directly giving this. Very good, very good. Thank you so much. Right. So that means we are through with the problems. Right. So we are able to at least do. So we are able to at least analyze what is exactly happening if at all we are having an equation like this. Got it? Right. Now, a small question. You got something function f equal to, what is this? C dot. Help me out.
C dot under bracket A plus B. That's the
This one.
dual.
This is the dual. That's it. Fine. For this,
Only
f
C, not bar.
C not the bar. Only C or C
Ma'am,
bar?
only C. Only C. Only C.
Yes, ma'am, only C.
Okay, fine. You got like this, right? C dot A plus B. Okay. So for this one, you got minimization of function. How much you got?
C plus A dot.
C plus A bar
AB.
AB.
A.
No, ma'am.
B.
C plus A dot B. Yes, ma'am.
Is it?
Yes,
Yes,
ma'am.
ma'am.
Yes.
Yes.
Right.
Ma'am.
So you got this. Okay. Till now we are only with the functions, right? So a little better masala we will add here, right? We will try to draw the circuit also. Okay. So now drawing the circuit is now an art, right? So logical circuit drawing, you can have exclusively inputs shown, then afterwards the gate utilized, then the output. So I have no idea how it was taught in your normal class. So can you, if you can brief me, I will proceed in that manner. How it was taught? Diagram? Yes. How it was? See, I'll write that. So A, B, C are the inputs. So whether required or not required, and then we will have NAT combinations also, not combinations availability. If required, we will use, otherwise they will be lying there. So this is available, laboratory available course. So we have this, we have a NOT gate also available in the breadboard itself. Okay, so now in order to make this function f, what I have to do? C plus AB, na? So I want C, right? Prior to that, AB is required. So that means A dot B, all output. Okay, then afterwards you require a OR gate. Is that correct? So this is your actual enclosure. Inside that, this is gate 1 and this is gate 2. That's it. And these are available inputs. These are inputs. Right? So you can neatly frame them. Otherwise, you need not show them also because they are not being utilized. So you can just this is the logic diagram. So now in the logic diagram, for this particular problem, you have how many gates? You have 2 gates. One is an AND gate and one is a NOR gate. Don't you see it's a mixture? I have a basic gate, 2 basic gates. Correct. Now in my circuit, I don't want to see any basic gates. In fact, I want to see only 2 input NAND gates. That means I want here inside my box only universal gates. Is it possible? Is it possible to realize? Yes, it's a question. That means
Yes.
my
Yes, ma'am.
Yes, ma'am.
so my box, this green colored and green colored, this AND gate should be replaced with only NAND gates. This one also should be replaced by only NAND gates. That means I'm just trying to check out whether you have the basic knowledge how a NAND and how it can be realized. Sorry, how a AND can be realized using NAND gates. How many minimum NAND gates is required to realize a 2 input AND gate? Two input AND gate. So this AND realization gates is required?
2.
Yeah. So I will have like this, right? Now, if at all, I will again send it through another NAND gate. Okay. So did you understand what does this means? Both we are feeding with the same thing. Okay. So you will become AND gate. So I will have 1 and 2 in place of this one. Is that correct? This AB in a requirement. So I have used. So I can go and fix it there. Is that correct? Yeah. So now
Yes.
to get an OR gate for this second gate, OR gate realization, how we can do using only NANDs. That's my target. OR gate, how it will be? OR gate means what? Some X plus Y I should get, but I should have only NANDs in that. So you can use your De Morgan. Am I getting that? Is that fine? See, this is Y bar. Yeah. So X bar, Y bar. So X bar, Y bar, whole bar. This is what happening here. So it can be X plus Y. Is that correct? What is that law? What is that law? De Morgan only, na?
De Morgan's law.
Yeah, De
Yes,
Morgan's.
ma'am.
So that means minimum requirement of 1, 2, and 3 gates. That means an AND gate, a simple 2-bit AND gate requires 2 NAND gates to realize. A simple 2 input OR gate requires 3 2-input NAND gates to realize. So this mixture and this mixture over here, I will combine. So now, how many gates will be there to realize that function? Our function C plus AB. So 2 over here, 3. Is that correct? So my X is what here? My X is AB for me. And Y is C. Is that correct?
Yes, ma'am.
Yeah. So like that only you have to go. Right? Now, in that, can we further reduce? See, that's what I was telling. See, here, this one gate here. Okay, then only AB, is that correct? So, A, so now, after this, my OR gate will start. OR gate means over here. So, AB, another.
Your video
Ma'am,
is
your video is lagging.
very.
Might be some net issues.
This C is so what? So, what happened?
Ma'am, your video is lagging.
Poor connection, I think, no?
Yes, ma'am. Audio is coming after the video.
Here, I think it's fine. I don't have any delay on here. I think now it's getting registered, huh? Then that means might be at your end, ma. So now here AB whole bar is coming. Then afterwards, this will be your final. Okay, now see here carefully. Here I have AB bar. Again I require AB bar. I am wasting this gate, right? Just see. This one and this one are the individual realizations. I have fixed them. Right? And I am having a further reduction. Just see. I wanted to have here AB bar towards here. But in between I am wasting another gate. So I can rather reduce that and reduce this and directly utilize here. Is that correct? Can you see?
Yes, ma'am.
Directly I can fit there. So how many I require? Oh, I'm so sorry. So I have one gate, then afterwards this gate, another gate. So A, B, C. So A, B, whole bar. This one is C bar. This is my F. Is that okay? Is that my final? Is that fine? Is that fine? Just check out using NAND
Yes,
gates.
ma'am.
Yeah.
Yes, ma'am.
So that means what we are trying to see here. What we are trying to see here. Just a second. Just a second. These people will kill me. If there right. If you have any flaws there, just find it. That means here what did we do? Here it's a little elaborate explanation. I used basic gates to realize F. Right? I'm not satisfied with that. I went for universal gates. So where each gate is utilized. Then this is the combination of the whole. Right? Again in this, I have seen the gates are getting repeated. So I have further reduced. Okay, so now this is called a two-level circuit diagram. Two-level logical diagram. See here, this is called scratch. We will start from a scratch, basic gates. And this is the final versions. Right, now you people are all interested in the VLSI and all because that's a booming subject. Right, so now you tell about your knowledge, like whatever you have acquired. Using these gates and these gates. Right, there is a difference. What is that? The reaction for the inputs. These gates are supposed to be fast gates, little fast gates. We don't have delays here. I cannot say we don't have delays. There are delays, but not like this. The propagation delay for the signal here is very low. Right, now second point is this type of gates are very easily available. Easily available means in the sense we wanted money. Less amount of money. These universal gates are very easy to get also. Right? So that means low cost it is. So instead of NAND you can use NOR also. Doesn't matter. Okay. So now what is happening? Here a small flaw is there. That's what I was telling. It's a two input now. Right? Two input. For the two I am feeding the same input. Okay, so right. So now in this situation, what is happening? I can use a basic gate structure or I can use a universal gate structure and realize the function. Is that correct? Easy? Yes or not? No response. Am I there in the meeting or somebody has muted me?
Yes, ma'am.
Yes, audible.
Yeah, I am audible. Okay, fine. I am in. Right. So do one thing. Let's do the same procedure totally for a 4 variable. Okay, so in the 4 variable also I need this full level, right? So that 4 normal realization, then afterwards the circuit diagram, everything. So you can take down a function which is having A, B, C, D. Okay, its terms are 0, 1, 4, 5, 6, 8, 10, 11. Right? These are the min terms available. Right? So minimize F. Right? Then find dual F. Right? This is point 1, point 2. Right? Then 3, logic circuit in 2 input NOR only. Okay? 2 input NOR only. And 2 input NAND only. Right? So these are the levels. Let's start working it. So minimize dual logic. See here, in this virtual mode, each one has to help each other, right? See, if at all I'm doing and you people have switched on the computer and sleeping, I have, because it will be of no loss. After you come, immediately exams will be there. So remember, you will be doing your third semester exam, then fourth semester exam at a stretch. So imagine the burden, right? So in that case, try to work out every day whatever problems provided to you, so that you will at least get practice. Because at home, definitely you guys will not be having the mood to practice also. That is for sure. So
No,
at least in the
ma'am.
class you complete. Yes, ma'am? That's fact. That's fact. I can understand. I also barely get them. Right.
Very much burden, ma'am.
Very, very well. What to do? We are not able to help you, ma'am. Now, in fact, now the campus situation is much worse. Right, we have more cases in the campus because students have come, research students, and we are really in trouble. Now also that COVID meeting is there, we have to see. I don't know. Small hope has come in November, because students are coming back, our research students, and then now this has happened, I think, because of the IIT Chennai situation, Madras. So they have hundreds of cases just popped up. So what?
66 cases, IIT Madras.
No, active much more now. No, much more.
100 plus.
Yeah, it became 100 plus.
Yes, ma'am.
Yeah. Very bad. So when you people will come, first choice will go for final years. Then afterwards we should shoo them off. Then afterwards we should call the third year. Then your turn will come. I definitely don't. Okay. When that stupid vaccine kicks in and all will come, God only should know. We don't have any hope also. Right? So we something. I'm not keeping the complement forms in this, right? So just to not to look cumbersome, that's why. Otherwise, you can put also 0, 1. So these are the availabilities, correct?
Yes, ma'am.
Okay, now start working out. The best possible reduced one you see. Okay. Somebody is posted. Okay. Swarup. Do we have? Yes. Just a second. Swarup has posted something. Others also can see. No problem. So, Kritarthanath. Like, see, the minimal is the best and valid. So, if at all you can see, you can compare yourself. Oh, 1, 2, 3, 4, 4. Wow. See, everybody are getting 4, that is fine, but every term is having more than what? Kritartha, you just see Kritarthana. In your function, what is there? You have 4 terms, fine, but 2 terms are having 4 literals. That means all the 4 are utilized. Then in that case, I find, yeah, I find Swarups is better. Swarup is better. Then afterwards, I think Swastik also is better. Oh, Swastik got 1, 2, 3, 4. Yeah, same as Swarup. Yeah, same as Swarup. Then who else? But where is the logic diagram? Everybody are posting only the first 2, but logic circuit third one nobody is posting. Third one should be posted, please. Okay, somebody has posted. Sahil. Yeah, Sahil, you have posted. Thank you so much. But question is, I need the circuit diagram also, logic diagram. Anvesha. Yeah, minimize everybody got correct. But I am not finding anybody's circuit diagram. It takes a hell lot of time, ma'am. You can say, right? You have a graph next to me. Yes, Satya Ranjan Oja. Yeah, very good. Yes, ma'am. Do you have a class next to me? After me.
Yes, ma'am. Yes,
Okay,
ma'am.
whose class?
Yes, ma'am.
Yeah, that is
Machine,
Electrical.
electrical machine.
electrical machine. Okay, then I'll meet you tomorrow morning, 10 o'clock class. I need the diagram first. Okay, all the levels, what I have shown in that manner, right?
Okay.
Because 315.
Ma'am,
Yeah, what happened? What happened? So, yeah, go ahead.
ma'am, for the logic circuit, we can
Uh-huh.
use only 2 NOR gates or
No.
any.
Clearly see 2 input NOR gates. Not 2 NOR gates. Clearly I have written. You have, see, 3 input NOR gate is also available. I am asking 2 input NOR gate only. Just like,
Okay, ma'am,
yeah,
I got
please.
it.
Yes. Not only 2 NOR. 2 input NOR only. I didn't tell you how many NORs you have to use. I told NOR should be having 2 inputs. Any number. You can use 100 also, no problem. 2 input NAND only. Right? If at
Yes,
all I want it like that, now use only 2 input NOR gates, number of NOR gates to be used, I will provide it to you, if at all I want. Okay, so as of now, use 2 input NOR gates. Done? Anything else? Uh-oh, somebody is posting? No. Yes or no? Is that done?
yes, ma'am.
Good. Okay, so machines means your Rudra sir will be ready. Right? Rudra sir is taking or who is taking?
Yes, ma'am, Rudra sir.
Rudra sir.
This session, okay, and then. Okay, so tomorrow morning I'll meet you, but in the first start I should see how many people are giving me the question answer. Okay, post it and keep it. Otherwise, in the night also you can post it to me. Okay, right? So I'll see you tomorrow.